Today I'm going to demonstrate the strategy of partial products to help you better understand how we teach our 4th and 5th graders how to move from multiplication in a pictorial way, which is more of a picture, to representing it in partial products, and then finally move into the abstract method, which is the traditional algorithm that many of us were taught. So I'll use the problem 23 times 7. Our 4th graders will multiply one digit that can go all the way up to the thousands, and they will multiply it by a 1-digit factor. And so if we first start off with the area model, and to do that, the students will draw a square or a rectangle, and they expand 23, since 23 is really the value of 20 plus 3. Okay. And they're multiplying that by the value of 7. And then with the area model, the students will multiply the value of 7 times the value of 20 to get 140, and then multiply the value of 7 times 3 to get 21. We call these our partial products, and then students will add them together to get their final answer of 161. Once students have a good understanding of the pictorial way using the area model to multiply, then we move to the representational way, which we refer to as partial products. It's going to look very similar to the area model. It just takes out the drawing step and moves them to a more efficient way to solve multiplication problems. So using the same problem, 23 times 7, students will then first multiply the tens. So it would be 20 times 7 to get 140. Again, same thing they were doing over here. It's just shown a little bit differently. And then they will multiply the ones, 3 times 7, to get 21. These are known as our partial products. And then to get their answer or their final product, they add them together to get 161. Okay. Sometimes students, it's really helpful to have them write out the partial products and what they're multiplying. Some students, once they get faster and more efficient, will skip that step and they'll go right to just writing the partial product answers. And a lot of times students will use this method when they're solving things mentally because they can easily multiply factors by tens, and partial products allows you to do that very quickly. And then we move to teaching them the standard algorithm, which is the most efficient way, but also if students have to have a really good understanding of what they're doing. Otherwise, they're just doing a process and the understanding is lacking. So then we multiply the ones place to get 21. And then we're really multiplying by the tens place, but because we're recording that number in the tens place, we really say 2 times 7 to get 14, plus 2 more tens to get 16. And so we would get the answer of 161, which matches the other way. And students, when they're ready to move to the traditional method, they understand that 161 is really comprised of multiplying by the ones and multiplying by the tens. Okay. I'll show you one more example for 4th grade using like a 3-digit number times a 1-digit number. So let's say we had 146 and we wanted to multiply that by 3. Again, students would start in the hundredths place and they would do 100 times 3 to get 300. Then they would move to the tens place to do 40 times 3 to get 120. And then finally they would move to the ones place, 6 times 3 to get 18. Again, these are our partial products, and then students would add them together to get 438. And again, like I said, this is really mental, and a lot of students are able to kind of calculate these almost mentally without having to write much down. All right, now I want to give you a 5th grade example. So with 5th grade, the only thing that is different, we teach the same strategies in the same order, but the thing that is different is that 5th graders are expected to multiply by 2-digit factors. So same thing, we'll start with our area model. Students start with a square and they expand each factor. So 43 is really the values of 40 plus 3. Okay. And 56 is the values of 50 plus 6. Okay. And now students can kind of just multiply the factors together. So 50 times 40 would be 2,000. 50 times 3 would be 150. 6 times 40 would be 240. And 6 times 3 would be 18. And they would all add all of them up to get their final answer. Same thing, then we move to partial products where it's a little bit more efficient, a little bit faster. Okay, but same process. Student would start by multiplying the tens together. So 40 times 50 to get 2,000. Okay, and then 50 times 3 to get 150. It's important that when students are doing this, they are lining up their numbers in the tens, the ones, the hundreds. And then they move to the tens, the ones place. So 6 times 40 and 6 times 3. Again, we refer to these as our partial products, and when you add them together, you'll get your final answer of 2,480. And then finally, when students have a good understanding of partial products and able to write that representationally, then we move to the abstract traditional method of 43 times 56, where students are multiplying the ones, six times 4 plus one more 10 would give us 24, 25. And then they move to the tens place, putting their placeholder. 5 times 3 would be 15. And 5 times 4 plus 1 would be 21. Add it together to get 2,408. Again, students knowing that 258 is really comprised of 240 and 18. And 2,150 is what makes up 2,150. And that's how we teach partial products and how to multiply to our 4th and 5th graders.